All right, so let's see if we can finish off this chapter with this particular video. All right, so we were talking about deltas. I showed you that there's evidence of deltas on Mars in the last video, and we compare that to river deltas. Okay, so here this is kind of just answered this question. So this picture shows an example of what geological feature. This is actually a delta, right? Not a big surprise. All right. So the next thing, so we talked about water, changing the surface of the Earth as a liquid. It's built these huge canyons, including things like the Grand Canyon. It's created caverns. It's created sinkholes. Um, it's created caves in some places. All right. So anyhow, now we're going to talk about strictly surface. So glaciers. All right, glaciers have their. Remember, erosion is when things move. Okay, so the glacier is like a plow, a gigantic plow that just picks up rocks and sediments and just starts. As the glacier retreats, it'll deposit this stuff all over the place. Wherever the glacier has been, basically. All right. So there's two types of glaciers. There's what are called alpine glaciers that you find near mountains, and then there's of course continental glaciers. Those are the kinds you find. That used to cover a huge portion of the United States. As a matter of fact, were continental glaciers. There still are some, but they're more in the Arctic and Antarctic. All right, so and of course, with global warming, we're concerned about them, completely melting. All right, anyhow, a glacier is the accumulation of snow and ice thick enough to move under its own weight. Okay, so it always, of course, moves downhill, right? It's always moving from higher terrain to lower terrain. So keep that in mind. And usually, for something to be considered a glacier, you're talking about 50 meters thick or more, usually much more. But all right, so you have this huge block of ice, and it's like a river or something like that is frozen up. Okay, so as it says here, the glacier's mass has to be at least 50 meters thick, and it moves like a plastic. Where the entire mass will shift. And of course, what happens is underneath it, because you have this increased pressure, the water will tend to melt. The frozen ice will tend to melt, turn into water, and that will cause the glacier to flow, to move. They don't generally move really fast. But anyhow, that water melt at the bottom is called basal sliding. All right, so that's one way in which these things move. So that contributes. Of course, the big thing is gravity. Right, gravity is the thing that causes the glaciers to move. All right, so the mass of a glacier changes over time. So there's two opposing things that are going on. You get accumulation, which is snow and that falls onto the glacier that will eventually turn to ice and make it bigger. And the other is when some of the ice of the glacier melts or it sublimates. That is, it turns directly from a solid into a gas, so it turns into water vapor, or it simply breaks off. So that's called ablation. Right? So ablation is just the opposite of accumulation for as far as glaciers go. So alpine glaciers, develop, as I said before, develop in mountainous areas. They're confined to a certain valley. And examples of when we see these alpine ones would be like the Cascades, the Cascade Mountains in western United States, the Rockies, also in western United States, the Andes in South America, and of course the Himalayas. The erosion of of landforms. So these are some different areas that that's I'm not going to even try to pronounce these first two. So Horn, Hanging Valley, and U-shaped valleys. All right. So these are French terms. All right. So when glaciers melt, they drop poorly sorted, heterogeneous. So heterogeneous just means different sizes of anywhere from boulder size to pebbles to sand to clay. You get a wide range of particles, and it's the hallmark of the differentiated glacial sediments. And so the glaciers will go to this point called so this is like the furthest that the glacier is going to get is called the terminal moraine. The terminal moraine is that's like how far usually the glaciers are going from from colder regions, so further to the north and seeping south. Or if you're in the southern hemisphere, of course, it would be the opposite. This would be the south towards the South Pole, and this would be towards the equator. All right, so that's perfectly fine. One of the things they dig out these enormous. They make these huge marks in the ground, and so you can actually not always, but usually you can tell what direction the glacier was going in. So I was just mentioning this, that I found this in the textbook as a nice little picture of, so these marks that a glacier leaves are called striations, and you can see the striations in this rock right here. I also wanted to go back to, let me go back a little bit. Oops, that's too far back. I wanted to go back, to this picture right here. This is called a crevasse. And these can be, you find these in glaciers. These can be very dangerous. People like to hike in glaciers. That's not exactly my thing, but whatever, right? Different strokes for different folks. But so that can be very dangerous. I just wanted to show a nice picture of that. So here is what is this? This is just showing some more flow. So it can either be normal, where it's moving at a constant rate, or there can be a surge flow. If it suddenly falls down a hill or something like that. All right, so let's keep going here. Back to the slides. All right, so we did that. So what else do I have? Anything that's so when glacier ice melts, it drops poorly sorted. I just talked about this. One of the things that to note is, for example, the Great Lakes and the Finger Lakes in upstate New York, and even the Minnesota, right, which is sometimes called the land of 10,000 lakes. The glaciers carved out that land where these lakes are, including the Great Lakes, the 5 Great Lakes. I originally grew up in New England, and there are incredibly large boulders all over New England. If you try to do a little farming or something like that on your property, you're almost always running into these huge rocks, and that comes from the last ice age, as a matter of fact. All right, so it's just different for different areas. All right, so then we turn to the wind. Of course, the wind is constantly interacting with the land to change the land, right? It sculpts the land. Not as much as water, certainly, but it does have some impacts when you have very strong winds. Of course, any time you can have extremely strong winds, volcanoes, things like that. All right, so you can move surface particles. One of the things that we find is the Sahara Desert, which of course is in Africa. We've found little pieces of it, little sand particles, as far away as in the Caribbean, and other places. In other words, the wind, if these sand particles can get trapped in the jet stream, they can travel, virtually almost all the way around the world. All right, so that is an example of what goes on with the wind. There's many erosive agents that sculpt the Earth's surface. Overall, the overall erosive agent that does the most work, of course, is water, right? Running water. Oh wow, am I done with it? Let's see. Do I have anything more to say about? Hold on, let me go to the. Let me go. So sometimes it's better when I look at the textbook. See if there's anything more to say. It's the wind. This is about glaciers still. More about glaciers. Some nice pictures. This is that's up in Juneau. Juneau is really beautiful. I was when I was in the Navy. My ship went up to Juneau, and I actually got to go see a glacier, which is kind of cool. Let's see what else. This is just some more evidence of glaciers covering the Earth. They talked a lot about dunes. That of course the wind can affect the sand around the Earth. Yeah, all right. I think that'll be about it. And that is the end of chapter 22.